Hi guys, welcome to my YouTube channel. I'm your tutor, Mr. Baraka, and today I want us to go through chemistry paper 2 so that we remind ourselves a few things as you prepare for your chemistry paper 2. Now look at the first question. You are given a flowchart and then you're supposed to study the flowchart and then you answer the questions that follow. So look at this flowchart. If you look at it properly, you're able to understand the type of industrial process that is involved. And for part A, identify the industrial process. If you look at this process, at the end of the day, you're actually getting what? You're producing sodium carbonate. So this industrial process is what we did in from 2 carbon and its compounds. So the process is Solvay process. So this is the correct answer. The industrial process is Solvay process. Then you go to the next part. The next part says you name solution A, substance B, and solid S. If you look at solution A from the flow chart, you can see this is ammonia getting in, and then solution A gets in, and then they form substance B, and then they go to reaction chamber 3. So solution A, the correct answer is supposed to be brine. So you can say brine, or you can write concentrated sodium chloride. So any of them is okay. We accept concentrated sodium chloride, or you can say brine. And then part B, substance B. Substance B, if you look at the flow chart, you locate where B is. B is here, this arrow. So this is what? Ammonia gets in, and then you have brine. So whatever comes out of chamber 1 is actually what? What we call B is ammoniated brine. So it is brine mixed with what? Mixed with ammonia. You can also accept if you say ammoniacal brine. Any of them is okay. Ammoniated brine or ammoniacal brine. And then solid S. If you look at solid S is the one that forms what? Sodium carbonate if you do process 2. So if you look at solid S, there's a process 1 here that produces what? Solid S and ammonium chloride. So these two, solid S and ammonium chloride, they are coming from reaction chamber 3. So actually what happens is that the reaction that happens in chamber 3 produces what? Ammonium chloride, which is in solution form, and then solid S. So it means you have to filter so that you get solid S and ammonium chloride. So the identity of solid S should be sodium hydrogen carbonate, so that when we heat sodium hydrogen carbonate, now we're able to get what? Sodium carbonate. So solid S is supposed to be sodium hydrogen carbonate. Then we go to part C. It says you write the equation in chamber 2. So we locate chamber 2. Chamber 2 is here. Chamber 2 is being fed with what? Ammonium chloride, and then there's calcium oxide here mixed with water. That means you form calcium hydroxide. So calcium hydroxide and ammonium chloride, they meet in chamber 2, and then a reaction takes place and ammonia is produced with other products. So for this reaction, the equation should be you have ammonium chloride, which is a solution, plus calcium hydroxide. After you slag it, adding water, you slag calcium oxide, you get calcium hydroxide. So it will give us what? It gives us calcium chloride, gives us calcium chloride. It also gives us what? Ammonia gas, and also it gives us water, H2O. And then you balance the equation. You balance the equation by putting a 2 where you have ammonium chloride and a 2 where you have ammonia, and a 2 where you have water, so that now the equation becomes what? Balanced. So this is the correct chemical equation for the reaction taking place in chamber 2. And then we go to chamber 3. Chamber 3, if you look at chamber 3, you can see where chamber 3 is. It is here. So ammoniacal brine comes in, then there's carbon dioxide. A reaction takes place here that will give us what? Solid S, which we said is sodium hydrogen carbonate and ammonium chloride. So what happens? You will have sodium chloride, your brine, plus exactly aqueous, sodium chloride aqueous, plus ammonia gas, plus water, plus the carbon dioxide. All these are fed into chamber 3 so that it will give us what? Two products. The first one is sodium hydrogen carbonate, which is a solid, and then the other one is a solution, which is ammonium chloride aqueous, and the equation is balanced like that. Then part D says identify process 1, and we said process 1 from the flow chart, 1 was filtration. So we have to filter the mixture of ammonium chloride and sodium hydrogen carbonate so that we get the solid, which is sodium hydrogen carbonate, and then the solution is ammonium chloride. So process 1 is filtration. And then process 2, we said that for you to move from sodium hydrogen carbonate to sodium carbonate, you have to heat. So the process there is called thermal decomposition. You have to use thermal decomposition to break down sodium hydrogen carbonate to give you sodium carbonate. And then you are told part E, you give a reason why the industrial process above is very efficient. It is efficient. Reason is because most of the substances that are used in the process are recycled. They are recycled, and because they are recycled, it means then you reduce what? You reduce the cost of production. Most of the substances are recycled, hence cost of production. Cost of production is reduced, and also environmental pollution is reduced. So you can see carbon dioxide, instead of it being released in the atmosphere, it is recycled. So it makes the process to be very efficient. You recycle most of the substances like ammonia, carbon dioxide. So at the end of the day, the cost of production is reduced, and also environmental pollution is also what? Reduced. So it makes this process to be very efficient. And then F says you give two uses of what? Sodium carbonate. You always give industrial uses because it is produced on large scale. Industrial uses. The first one is that sodium carbonate is used in manufacture of glass. It is also used in manufacture of paper. It is also used in manufacture of soap. So you give any two and you will get what? Your 2 marks. And then the last question says that name one substance that is not recycled or not reused in the process. There's one substance that cannot be recycled, and that substance is actually what? Calcium. We are naming calcium chloride is not recycled. So this is the substance which is not recycled, calcium chloride. And the role of this calcium chloride is it can be used as what? Used as a fertilizer. Can be used as a fertilizer to add calcium ions in the soil. That is one of the roles. Number 2, it can also be used as a drying agent. Can be used as a drying agent. So most gases can be dried using what? Calcium chloride. So it can be used as a drying agent. Now, question 2. An experiment was done to determine what? Heat of combustion of ethanol, and the results are shown there. You can see, can follow through the information that is there. And then the first part says that you calculate the mass of ethanol that was burnt. And you can see the mass of what? Ethanol and the burner at the start, and then mass of ethanol and the burner at the end. So what do? You simply take 86.66 grams minus 86.20 grams to give you the mass of ethanol that was burned. In this case, the mass is 0.46 grams. Then, amount of heat in joules. Amount of heat in joules, it means you are looking for what? Enthalpy change delta H, which we said is mc delta T, where m we said is mass of solution. So what you do is that you just take the volume of water, you multiply by the density of water, you will get the mass of solution. C is the specific capacity, which is given there, 4.2, and then change in temperature is what you will get from here, the final temperature minus what? Initial. It gives you delta H. So m is actually what? It will be 200 times 1 to give us what? 200 grams. And then delta T is the higher temperature, 39.0 minus 24.0 to give us 15. Gives us 15.0 degrees Celsius. Then when you come here, the mass is 200 times capacity is that, and then delta T, you take it the way it is, 15. Just don't ignore the unit, just write 200 times 4.2 times 15. Whatever you get here will remain in joules, and joules is capital J. And the answer to this is actually what? 12,600 joules, because the question says you give your answer in joules, so it is 12,600 joules if you calculate. Then the other one says molar heat of combustion of 1 mole of ethanol, and you are given relative atomic masses. So what do we do here? The first thing is what? We look for the moles. The moles of ethanol. Ethanol is written like that was burnt. So ethanol you used. It is given by mass over molar mass. The mass is 0.46. We got it up there. And then you divide by the molar mass. The molar mass is from the formula. So the formula is C2H5OH. That means that every carbon here is 12. You have 12 times 2 carbons like that. Plus hydrogens are 6 and each is 1. So 1 times 6 plus oxygens is 16 and we have 1. So it is 16. This one gives you what? 46. So you divide by 46. It gives you 0.01 moles. So that means that if you burn 0.46 grams, you are actually burning 0.01 moles of ethanol. And then when you burn these moles or this mass, the amount of heat energy that you release is actually 12,600 joules. What if it is 1 mole? So you burnt 0.01 moles and you release this. What about 1 mole of ethanol? What would be the answer? You'll have answered the question. So in this case, what do? You say that 0.01 moles are equivalent to, you can see from here, 12,600 joules. What about 1 mole of ethanol, it will be equivalent to what? So you cross multiply. So you have 1 times 12,600 divided by 0.01 moles, and then now the answer, you must show the sign, whether it was exothermic or endothermic. And we said all combustion reactions are exothermic, so heat must be released. So negative, we get a negative there. Negative 1,260,000 joules per mole. If you decide to convert this into kilojoules, you divide by 1,000, so you'll have what? You'll have 0.01 moles equivalent to 12.6 kilojoules. That's an alternative. And if you use that, then here you'll have what? A total. You will say 1 times 12.6 kilojoules over 0.01, and your answer here will be negative 1260 kilojoules per mole. So you can give it in joules per mole, or you can give it in kilojoules per mole, which the answer will be negative 1260 kilojoules. Small k, capital J, kilojoules per mole. If you divide by 1,000, you get kilojoules per mole. Then you are told, write what? A thermochemical equation for the combustion of ethanol. Thermochemical equation means you write a complete balanced chemical equation using 1 mole of the substance, and then at the end you show the molar heat of combustion. So in this case, we said ethanol is written like this: C2H5OH. So it must be 1 mole. You have to burn 1 mole plus oxygen gas, and then we get carbon 4 oxide plus water. So here there will be a 3 to balance, and then here you have delta H of combustion, molar heat of combustion. So this one must remain 1 mole. So here it means I'll have what? 3. I'll have 3 to balance. So 1 mole of ethanol will release when it is burnt completely. It gives you negative 1260 kilojoules per mole. This is the thermochemical equation. This is the thermochemical equation. Part C, you are told to draw an energy level diagram for combustion of ethanol. So from there, from that equation, you can see the reaction was what? It was exothermic. So what you do is you draw something that looks like that. So for X and Y, what do you have on the Y-axis? You have energy content, or you can say energy level, and then this side you have what? Reaction path, like that. And for you to draw, you have to know the reaction. So you said it is exothermic. It means the reactants have a higher energy content, products have a lower energy content. So it means then reactants will be up here. Reactants are up here. And which are the reactants? It is your ethanol plus the 3 oxygen molecules, like that. And then now products will be down here. The products are here. Products are here. So this is the product. The product 2 carbon 4 oxide plus 3 water molecules. Now every time you are drawing an energy level diagram, we show activation energy. So we are moving from there, we are moving from here. So you draw a kahil like that, and then you come down like that. So you're moving from here down that. So it means then you are able to show, actually this is how you show it. From here up to here, this one is the activation energy for the reaction, and then from the level of reactants and the level of products, this one is your delta H of combustion, which you said is negative 1260 kilojoules per mole, like that. Then you are told, I hope you can see clearly. So this is how you will draw it. It is good you show activation energy, and then now you show the molar heat of combustion for this reaction, like that. And then we now come to the last part of this question, which says that you give 2 reasons why the empirical the experimental heat of combustion value may be lower than the theoretical value. And the reason is because there are some possible errors that happen during the experiment that makes the value to be lower than the theoretical value. And these are the answers. The first one that you can give is that it may be due to loss of heat energy to the surrounding. During the experiment, some heat energy may be lost, and therefore that energy cannot be accounted for, so it makes the value that you get lower than the theoretical value. Sometimes there is what? Incomplete combustion of the fuel that you are using, which is ethanol in this case. So at the end of the day, you get a lower value than expected. Another one that you can give is that sometimes during the cooling process of your ethanol, some of the ethanol might evaporate. So evaporation of some ethanol during the cooling process. This means then the final mass of ethanol and the burner that you have may be lower than the expected. So that means that the value that you get at the end will be affected. It will be a lower value than the theoretical value. So those are the reasons why the value from the real practical experiment may be lower compared to theoretical value. Question 3. Question 3 is in electrochemistry, and you can see you are given potentials of some elements, and the letters are not the actual symbols. And then these elements were actually connected to what? A half cell of copper. So you have copper 2 ions and copper. So the metal ions are now these ones. You use these ones and then connect them to what? The half cell of copper, and you get you can get now the electrode potentials for the full cells. Now the question says that what is metal R? Give a reason. So the answer is very simple. The answer for this question is very simple, and the answer will be metal R must be copper. Why is metal R copper? It is because we are using copper here, metal, as the reference. The reference what? Electrode. So we are comparing all these other metals to the potential of copper. And because we are using copper as a reference, then the reference electrode is always having what? A potential of 0.00 volts. So copper must be metal R, and for this reason, it is because it is being used, copper is being used, or R here is being used as the reference electrode, and it has an electrode what? Potential of 0.00 volts. That is why R must be copper, because here we are using copper as the reference. So the reference electrode must always have a potential of 0.00 volts. Then which of the above metals is the strongest reducing agent? And you give a reason. For you to get the strongest reducing agent, you always look at the potential. If you are a reducing agent, you will have a negative potential, and the one that is having the highest negative potential will be the strongest reducing agent. So in this case, if I look at this one, the answer is P. It is element P, or metal P. Reason: it has the highest negative electrode potential of negative 1.10 V. You have answered the question. Then, strongest oxidizing agent, give a reason. For you to get the strongest oxidizing agent, you look for the element that is having the highest positive potential. So in this case, the answer is T. Why T? Is because it has the highest positive electrode potential of, now you give the potential, positive 1.16 volts. Like that, you have answered the question. So always for strongest oxidizing agent, you look at the highest positive. Strongest reducing agent, you look at the highest negative value. The element will give you the element that is having what? The strong that is being used as the strongest reducing agent or the strongest oxidizing agent. Then we go to part C. Part C says you select what? Two metals that will produce the largest potential difference. In other words, the largest EMF. For you to get the largest EMF, you always look for the element that is having the highest negative potential and the highest positive potential, the strongest reducing and the strongest oxidizing. If you locate those two, then they will give you the largest EMF, which is what we call the potential difference. So in this case, the answer will be the strongest reducing is P and the strongest oxidizing is T, because T has the highest positive and P has the highest what? Negative. That is how you answer that question. And then you are told part 2, calculate the potential difference of the cell chosen in C Roman 1. So you have chosen P and T. Strongest reducing, strongest what? Oxidizing. It will give you the largest EMF. Now you calculate the EMF. And you will be guided by the table, because the table has given you the potentials of the two elements. So it means you just come here and write that the E naught of the cell, in other words, the EMF of the full cell, it will be given by the potential of P and the potential of T. So you always start with what? The element that undergoes reduction, which is the oxidizing agent, and therefore it will be the potential of T, which is positive 1.16 minus, into brackets, negative 1.10, the potential of P. The total EMF should be positive to show that the reaction takes place. So positive, it will give you positive 2.26 capital V volts. You have calculated the EMF. So the EMF of the cell is given by the potential of the oxidizing agent minus the potential of the reducing agent, and it will give you a positive value, positive 2.26 volts. The next part says that you draw a well-labeled diagram of the electrochemical cell formed in C1. You picked the element P and element T, therefore you're supposed to draw a full cell for the two. And it's very simple. Always when you are drawing, the reducing agent will be on the left hand side, the oxidizing agent will be on the right hand side. So what do? We take the metal rod of that element P and we dip it inside what? A solution of its own ions. So this one is P solid, and then inside here I have ions of the same metal, and because the charges are not given in the table, we just assume that this is what? P2 aqueous, like that. And then the other side you take metal T, this one is T metal, the solid, and then you dip it inside what? A solution of its own ions, and because the charge is not given there, we just assume that is what? It is T2 aqueous. And then we say that the metal electrodes are supposed to be connected by a voltmeter, like that. A voltmeter and metallic wire. So you have metallic wires connecting to what? A voltmeter, like that. And then you put an arrow on. Can you see this arrow, like this one? This shows what? Electron flow. Electrons are flowing from the left to the right via what? The metallic wire. And then the electrolytes, the solutions, the electrolytes are supposed to be connected by a salt bridge. So this one is our what? Our salt bridge. So you indicate properly. This is salt bridge, like that. You have drawn a well labeled electrochemical cell and you'll get full marks. Then we go to the next part. Says that which one of the metals above cannot be displaced by any of the other metals in the list. You have seen the potential. We said if you are negative, it means you are a reducing agent. If you are positive, it means you are an oxidizing agent. So if you are to compare all those elements that are given in that table, you will find that the element that cannot be displaced by any other is the element which is the most reactive. In this case, it must be P. Reason is because it has the highest what? Highest negative electrode potential of negative 1.10 volts. Hence what? Strongest what? Strongest reducing agents and most what? Reactive. Actually, is the most reactive what? Metal. So it cannot be displaced by any other metal from that table. So it is P. Has the highest negative electrode potential of negative 1.10 volts, hence strongest reducing agent and most reactive what? Most reactive metal. Then part E says that you explain the following, that Roman 1, in electrolysis of acidified water with platinum electrodes, the volume of hydrogen collected was twice the volume of oxygen collected. This one is very simple. Reason is because actually in water, if the water is acidified, what you will get from here is that you will get what? You will get hydroxide ions and you also get what? Hydrogen ions. So hydroxide ions will give you oxygen gas, then hydrogen ions give you what? Hydrogen gas. So the reason is actually the volume is dependent on what? The number of moles of oxygen produced here and the number of moles of hydrogen produced here. So what happens is this, that when hydroxide ions are being discharged, only 1 mole of oxygen is produced. So hydroxide ions are discharged to produce 1 mole of oxygen gas, like what you have here. We said the ionic equation for formation of oxygen is always like this. 4 moles of hydroxide give you 2 moles of water plus 1 mole of oxygen plus 4 electrons. So can you see, you are producing 1 mole of oxygen. Every time you discharge hydroxide ions, you only get what? 1 mole of oxygen. And then for hydrogen ions, while hydrogen ions are discharged to produce, hydrogen ions produce 2 moles of hydrogen gas, like what you see here. the 4 electrons that are here, they will be accepted by what? By 4 hydrogen ions, and then so you have 4 hydrogen ions plus what? Plus 4 electrons, so that you get what? 2 moles of hydrogen gas. So in reality, you produce 2 moles of hydrogen gas every time you discharge hydrogen ions. Here you produce 1 mole of oxygen every time you discharge what? Hydroxide ions. So at the end of the day, the volume of hydrogen is more than the volume of oxygen. So to be precise, it will be twice the volume of what? The volume of hydrogen oxygen that is produced during electrolysis. Then the last part for this part C is actually what? You are told to explain why sodium metal is a good conductor of electricity, but solid sodium chloride is not. And we said that the reason is very simple, that sodium metal has delocalized electrons. It has delocalized electrons in its structure. That is why it is a good conductor, while solid sodium chloride has ions in fixed position, hence ions are not mobile, and for that reason solid sodium chloride cannot be a good conductor like the sodium metal. And then F says that you draw a well-labeled diagram to show how impure copper can be purified by electrolysis. And this one is simple. What you do is that you draw a beaker, and then every time you want to purify a metal, the impure metal is used as what? We use it as an anode, and then the pure metal, the same metal but pure, is used as the cathode. So what will happen is that you connect the impure copper to the pure copper via what? Dry cells, like that. So this one, you can see the small line, this one is the cathode, and this one the long line, this one will be what? Will be the anode. So this one is our impure copper anode, and this one will be what? Pure copper cathode. All these electrodes or these metals, they are dipped inside what? A solution of the same metal. So the solution here is what? We use copper 2 sulfate solution. Concentration standard is 1 molar. So what happens is that now this metal goes into solution. If it goes into solution, the copper ions come this side, and then copper will be formed on the surface of the pure copper. So all this copper that is here will be formed here, and then impurities fall to the bottom of the beaker. So these are the impurities, and the impurities we call them what? Sludge. So sludge are the impurities that are formed during electrolysis, like that, and you get your full marks. Then we go to question 4, and question 4 you can see from there that there's a flow chart. You see the flow chart is there. There's a flow chart: sugar solution, substance A, crude ethanol, process X, all the way up to the end. And then you study this flow chart, and then you answer the questions that follow. So the first part says that we name substance A, then there's X, process X, all the way up to the end. So if I look at what I have here, substance A from the flow chart is actually what the answer should be yeast, because it is fermentation. You're fermenting sugar solution to give you ethanol. Then process X from the flow chart, you will see that it is what? Fractional distillation. You distill ethanol so that you make it more pure. And then substance B is actually what? A metal. The metal is sodium metal, to give you what? Hydrogen gas. And then D is actually dehydration, so you'll get what? From ethanol you get ethene. You dehydrate the ethanol, you get ethene. And then ethene you polymerize, you get what? Polyethylene. You get polyethylene. Polyethylene is what you will get. And then you are told identify type of polymerization. Polyethylene is formed by addition. So this one is addition polymerization. So you just add one monomer to another. This one is unsaturated, so ethene, another ethene, is addition polymerization. Then what is the effect of continued use of polymer E? We said that the polymer is polyethylene, so polyethylene is non-biodegradable. It is not easily broken down by bacteria or microorganisms. Therefore, it means it can stay for a longer time in the environment and therefore causes what? Pollution. So you see it's non-biodegradable, hence causes what? Environmental pollution. Causes environmental pollution. And then you are told, part D, if 1 mole of sugar produces 2 moles of pure ethanol and 2 moles of carbon dioxide gas as the only products, write an equation for the reaction. So now we are giving the fermentation process, the reaction, the equation. So glucose is 6, so sugar is, now we're using glucose, C6H12O6. And then what do we have here? We have yeast. And then you're told you're producing what? 2 moles of ethanol. So ethanol like that, 2 moles of ethanol like that, and then you're told 2 moles of carbon dioxide like that, and you have answered the question. So you produce 2 moles of pure ethanol and 2 moles of carbon dioxide. The equation looks like this, and it is balanced. Then you are told how many moles of sugar are there in 144 grams of the sugar molecule, C6H12O6. The first thing is what? You just look for the RFM of this one, C6H12O6. Every carbon is actually 12, so there are 6 of them, plus hydrogen is 1, and there are 12 of them, and then every oxygen is 16, and there are 6 of them. The total, if you add, you get what? 180. Now once you get that, then what do? You get the moles. So the moles are there. We have moles of the sugar will be given by mass, which is 144, divided by the molar mass, which is equivalent to RFM, 180, and then you get your answer as 0.8 moles. So 144 grams of that sugar will contain 0.8 moles. The next part says that how many moles of ethanol will this amount of sugar produce? So if you go back to the question, you are told that 1 mole of sugar produces what? 2 moles of ethanol. So it means then it is very simple. We just come and write here that 1 mole of that sugar produces what? Ethanol, and the ratio in terms of the mole ratio is 1:2. So from the calculations that we have had here, we saw that the moles of the sugar, if it is 144, it is 0.8. That means that the moles of ethanol from 144 grams will be 2 times 0.8, and this one gives you what? A total of 1.6 moles of ethanol being produced. So if you use 144 grams of sugar, you'll get 1.6 moles of ethanol being produced. And then part 4 says, what mass of ethanol corresponds to the number of moles in D, Roman 3 above? So if you want to get mass, we said mass of a substance is given by moles times what? The molar mass, or RFM. And we know the moles is 1.6, the RFM we said, okay, you can do it, is here. It is carbon is 12 and there are 2, plus hydrogens are 6, 1 times 6, plus oxygen is 16, the total is 46. So you multiply by 46 and the answer will be, the answer is 73.6 grams. The units are in grams. 73.6 grams. And then you're told, describe how the concentration of ethanol produced can be increased. So the ethanol that you have is not pure, so you can actually increase what the concentration by removing some of the substances like water. So you do fractional distillation of crude ethanol. The answer is fractional distillation of crude ethanol, and then there is further dehydration of the ethanol to remove the water using calcium oxide to obtain absolute ethanol. So it means then when you do that, the concentration of ethanol will be high. So you do fractional distillation of crude ethanol, and then after that you dehydrate the ethanol using a suitable dehydrating agent like calcium oxide, and you get what? Absolute ethanol, which will have a higher concentration. Then give 2 commercial uses of ethanol other than manufacture of alcoholic drinks. And the answers are there. Ethanol is used as a solvent in preparation of drugs. You can also say that it is used in manufacture of synthetic fibers such as PVC, polyvinyl chloride. Others are like polyethylene. So you can use any as a solvent in preparation of drugs or manufacture of synthetic fibers such as polyvinyl chloride, or you can say polyethylene. Any of them are synthetic fibers. Now last question for this part. You can see here there's a diagram that shows the extraction of sodium using Down's cell. So you look at this diagram properly. There's a gas A, there's a substance B, you have a steel cathode, you have graphite anode, you have a steel diaphragm, and you have sodium chloride getting in. And then you're told name gas A and substance B. Actually gas A, the only gas that we have here is what? Is the chlorine gas. So chlorine gas is the one that is formed at the anode, because whatever we have there is what? Sodium chloride. So it is broken to give us what? Chloride ions and sodium ions. So chloride ions are negative, they go to the positive, the anode. So you'll get chlorine gas coming out as gas A. And then substance B will be our what? Our molten sodium. Molten sodium now comes out through the cathode, because sodium ions are positive, they are attracted by the negative side, which is the cathode, like that. And then you are told during what? Electrolysis, a certain substance is added to sodium chloride. Name the substance. So because sodium chloride has a very high melting point, we add an impurity, and the impurity is actually what? Calcium chloride. Calcium chloride is added, and the role of this substance is what? It is to lower. It lowers the melting point of sodium chloride from, so you remember the temperature, 800 degrees Celsius to 600 degrees Celsius. It lowers the melting point of sodium chloride from 800 degrees Celsius to 600 degrees Celsius. So what do you do with that? It means you save, hence what? Saves on electricity. The amount of electricity used, reducing what? Costs of production. So when you lower the melting point from 800 to 600, the amount of electricity used is saved, and therefore cost of production is also what? Reduced. And then, why is the anode? You explain why the anode is made up of graphite and not steel. The reason why it is made up of graphite, you can see from there, graphite anode, not steel. It is because of the product that is being formed at the anode. Steel, if it was steel reacts with chlorine. So once you are producing the chlorine and you are using a steel anode, it means then the gas produced will be reacting with your steel, with your anode, and that will not be very good. So we use what? We use graphite because graphite is inert. Graphite will not react with what? It doesn't react with chlorine because it is an inert electrode. It will not react with chlorine because it is inert. Graphite is inert. And then you're told, state 2 properties of sodium metal that makes it possible to be collected as shown in the diagram. You can see we said substance B is molten what? Molten sodium. Why is it being collected like that? There are 2 things that makes it to be collected like that, and the first one is here, and the answer is here. The answer is what? The first one is it is because the melting point of sodium is lower than the electrolyte being used. Melting point is lower than electrolyte being used. The other one is that sodium is less dense than the electrolytes. That is why it is very easy for you to separate molten sodium and the electrolyte being used. Is because of those 2 properties, that it has a lower melting point than the electrolyte. It is also less dense than the electrolyte. That is why it can be collected as shown on the diagram. Then, what is the function of steel gauge diaphragm? You have seen the diaphragm. Diaphragm is there. What is the function of this diaphragm? And you can see it is separating the anode and the cathode, and the main reason is because of this, that it prevents, the diaphragm prevents sodium and chlorine from recombining. So it is not combining, it is recombining, because before they were broken down by the electricity in the cell into sodium ions and chloride ions. It was sodium chloride. Now we have formed chlorine gas and then sodium metal. If you allow them to come back together, then you will go back towards sodium chloride. So they will be recombining. So we say prevents sodium and chlorine from recombining. That is why we have that steel gas diaphragm between the anode and the cathode. And then you are told, write ionic equation for the reaction. Write ionic equation for the reaction which takes place at the cathode. The cathode is negative, so it attracts what? It attracts the positive, and the positive ions are also sodium ions. So you have molten sodium, it will accept electron to give you what? Molten sodium, like that. And that ionic equation is balanced. And then at the anode you have chloride ions which lose what? Electrons to give you what? Chlorine gas. 2 electrons are lost. So you put a 2 here and you balance. So there's no need of writing a 2, 2, 2 because you simplify, you have 1, 1, 1. So At the anode you have that, at the cathode you have that. And then the last part says you give one industrial use of sodium metal, one industrial use of sodium metal. And the first one is that we said this, that sodium is used as what? Used as a reducing agent in extraction of titanium. When you're extracting titanium from titanium perchlorate, you use what? You use sodium as a reducing agent. The other one you can also say that it is what? Sodium is used in manufacture of sodium cyanide. Sodium what? Cyanide used in extraction of gold. So you can use that as an answer. And maybe the other one is that sodium chloride. Sodium chloride is used as a food additive. Even that one can be an answer. So you give any one correct industrial use of sodium metal and you will get your mark. I hope that you have gained something that can help you as you prepare for your chemistry paper 2 2022. I wish you all the best and God bless you. Bye.